Hi everybody and welcome to Pankaj Sir's Echelon Tutorials, and after a long time we are going to start with a session on Igcse Maths. Okay, so let me write down for you. So this session is for Igcse. Subject is Maths. Okay, and the topic that I've chosen for today's session is something called variation. It's a very sweet and uh, a lovely topic, variation. Okay, variations. Now, what is this variations? First, I'm going to talk on that, and then I will be quickly moving to this exercise 10, in which we have a lot many problems to solve. Okay, but before that, I want to give you some concept clarity of this variations. Okay, so if the students who don't know much about what is variations, for them, let me tell you that there are two types of variation. One which is known as direct, and other one which is known as inverse. Okay. First of all, what is this variation? Variation means changes. Okay. Changes in what? Changes in two quantities, say x and y. Suppose you have two quantities x and y, and suppose these two quantities are changing in such a way that if one increases, the other also increases. If one decreases, the other also decreases. If this is the way the two quantities are changing with respect to each other, we say that there is a direct variance between them. So we talk it in this way: x is varying directly as y. This is one way of telling that. Second thing, you can also say that x is proportional to y. Okay. And the third way of talking it is x is you know now varying directly, or if you don't work this if you don't use this word directly also, then also it doesn't make any difference. So x varies, x or rather x is varying as y. Okay, so whether you use this word directly along with the word varies or proportional, it doesn't make any difference. Okay, but then if it is proportional to y or varies as y, or directly proportional to y or directly varies as y, all means one and the same thing. Okay, and this is written in this way: x, the first quantity, varies directly as y. This is the way you write it. Okay, x is directly varying as y. Okay, or x varies as y, or x is directly proportional to y, or x is proportional to y. So let me write that four statements. Okay, for this: x varies as y. Okay, it is also written as x varies directly as y. This can also be written as x is proportional to y. Proportional to y. This can also be written as x is directly proportional to y. Okay, so this is how you can write this particular statement in and you can read it in four different ways, right? Now that is one thing. Second thing is, this is known as a proportionality sign. This is known as proportionality sign. Okay, now if you want to remove this proportionality sign and replace an equal to sign, then you can always do that, but in that case you'll have to multiply the other side quantity with a constant k. So I'll have to multiply this y with k, so I'll get x equal to ky. So this is nothing but the same thing. Okay, but these two are both same thing, but here there's a equal to sign, here there's a proportionality sign. Okay, this is equal to sign. So whenever the two quantities, they are related with a proportional sign, okay, proportionality sign, and if you want to replace that proportionality sign by equal to sign, all you have to do is you have to multiply the other quantity on the right hand side by k. Okay, that will make it x equal to ky. Okay, now these are all basic things about variation that I want to tell you, because every now and then I'm not going to repeat this thing. So in a one go, first I'm explaining you the concepts and then I'll go with the exercise. Okay, so this is all about direct variance. Okay, now when we talk about indirect variance, okay, so this was all about direct. Okay, this is all about direct variance. Now let us talk about inverse variance. Okay, inverse variance में what happens, again there are two quantities x and y. Okay, but here what happens is when one quantity is increasing, the other is decreasing, or when one quantity is decreasing, the other one is increasing. Okay, so they are going in the opposite sense. Okay, when this is the thing, okay, happening between the two quantities, we say that x is varying inversely as y, inversely as y, or it can also be written as x is inversely proportional to y, okay, here you have only these two language, x varies inversely as y, or x is inversely proportional to y. Okay, fine. So these are the two ways you can write it, and if you want to represent it, then you'll have to represent this way. First quantity varies inversely means 1 upon, okay, and you'll write the second quantity y over here. So this is how a inverse relationship or inverse variation between the two quantities x and y is written using the proportionality sign. Got it? Now again, if you want to replace this proportionality sign by equal to sign, you have to do that this way: x equal to k multiplied by what is on the right hand side, 1 upon y. You can write this as x equal to k upon y. Is that clear? Now this and this are the same thing, that is x and y, two quantities inversely proportional to each other or inversely varying with each other. This is also the same thing, x and y is inversely proportional to each other or inversely varies with each other. Only thing is here you are using a equal to sign along with a constant k. Here you are not using equal to sign, here you are using a proportionality sign. Okay, so to summarize, direct variance between two quantity x and y, direct variance means what? It can be written this way, it can be written this way, and the meaning is if x increases, y also increases, or when x decreases, y also decreases. And when x and y are inverse variation. Okay, what is the meaning of that? You have to write this way: x varies inversely as y. Okay, x equal to k upon y. Okay, meaning is if x increases, y decreases, or if x decreases, y increases. So this is to summarize. Okay, 1 2 3 4, right? I hope you have understood the concept now. Okay, now we will come to the exercise directly, and I'll tell you how to solve the questions from the exercise, okay, one by one. So here we go with the exercise. Okay, fine. So here we are on exercise 10. This is from David Reyner book, the 4th edition, and this exercise 10 you will find on page number 183. Okay, 183 is the page number. Okay, so let us start with the very first question, question number 1 of exercise 10. Okay, the question says that rewrite the statements connecting each pair of variable using a constant k instead of proportional sign. Okay, so the A part of the question is S, capital S is directly proportional to E. Okay, it is read in this way: S proportional to E, or S varies as E. Okay, now the question is you have to write this using a k instead of proportionality sign. Okay, so the answer will be S equal to KE. This is what I explained you in my previous just now before this, I explained you this only. Proportionality sign, if you want to replace by a equal to sign, what you have to do, you have to just multiply it by a k. Okay. B is V proportional to T. Now this is all direct proportion. Okay, V is directly proportional to T, right? So if you want to replace this proportionality sign by equal to sign, you'll write V equal to K times T. So that's the answer. C is X is directly proportional to Z square, isn't it? Yeah. So if you want to replace by equal to sign, you can just write X equal to K times Z square. Okay. D is Y is proportional to root of X. Okay. So Y will be equal to K times root of X. All you have to do is just multiply by a constant K, whatever is there on the other side of the proportionality sign. Okay. E is T is directly proportional to square root of L. Okay. So T will be equal to K times square root of L. Now it's not necessary that you have to represent the constant by K only. You can represent by some other letter also. Okay. But it will have some constant value. Okay. And in the actual formulas, for example, T directly proportional to L. This is a formula in physics which is relating the periodic time, that is T, with the length of the pendulum, that is L. Okay. And these two are related in this way. The periodic time is directly proportional to the square root of the length of the pendulum, isn't it? So this K constant, in this case will be 1 by 2 pi. Okay, it is 1 by 2 pi. K is 1 by 2 pi. But we are not going into the physics part of it. We are just considering the mathematical part of it. There should be some constant. Okay, so K actually is 1 by 2 pi in this case, right? F is C directly proportional to R. Okay, now this C is nothing but the circumference of the circle, and it is proportional to the radius of the circle. So C will be equal to K times R. Okay, the meaning of this is when the circumference increases, the radius also increases, or when the radius increases, the circumference increases. This is the relationship. So it is a direct variance, right? When one increases, the other also increases. Now if you want to replace by equal to sign, it becomes C equal to some constant K into R. Now here in this case, the constant K is equal to 2 pi. Okay, why? Because circumference is given by this formula 2 pi R. You remember in mathematics you have circumference is equal to 2 pi R. So your K is nothing but 2 pi, which is a constant. So K is representing some constant. Okay, so you in this question, in this exercise, you need not write what is the constant K in every case. You have to just mention that constant over here. Okay. So F ke baad, let us go to G. G is okay, it is A, area is directly proportional to R square. Again, A will be equal to KR square. In this case, K will be pi. Okay, because area is equal to pi R square. Fine. So let us go to the next one. H. H is volume is directly proportional to R cube. So the answer for this will be volume will be equal to KR cube. Okay, and it is pi R cube. Okay, volume is equal to K volume is directly proportional to R cube, right? So volume will be equal to K into R cube. Now K is any constant. Now if it is a volume of a sphere, then the K value will be 4 by 3 pi, because the volume of a sphere is 4 upon 3 pi R cube, right? But as I told you, we are not going into physics. We are only concerning ourselves to mathematics. So that was question number 1 that we are done with. Let us move on to question number 2. Okay, fine. So here we go to question number 2. Now question number 2 says that this is the one we are doing, right? Question number 2 says that y varies as t. Okay, so I'm writing that in the statement form. Y varies as t. Now when they say y varies as t, it is understood that y varies directly as t. Okay, so y varies as t, so I'm writing this in this way. And if y is equal to 6, further he has written if y is equal to 6, okay, then t is equal to 4. T is equal to 4. So he is telling you that when y is equal to 6, t is equal to 4. Okay, calculate calculate. What is telling you to calculate? Number A, the value of y when t is equal to 6. That is one thing is asking me to find out. And B is asking you to find out the value of t when y is equal to 4. Okay, these are the two sub questions, A and B. Okay, now see how we are going to solve this type of question. Now this is a typical question on variation, direct variation. So what you have to do is y is directly proportional to t. Now this is the solution. Okay, now the variance ka relation it is given to you, y is directly proportional to t. Now immediately you write this in the equal to form, so y equal to kt. Okay, now one set of y and t is given to you. Okay, if y is equal to something, t is equal to something, that one set is given to you. Now that one set of value is given to you just so that you can find out the value of this k. Now replace this value in this equation, y equal to kt. So you'll get 6 equal to k times t is 4, isn't it? 4. So your k will be equal to 6 upon 4, which can be written as 3 upon 2. Fine. So k you are getting as 3 upon 2. You got the constant value. K is equal to 3 upon 2. Now this constant value you again substitute over here. So you'll get an equation y is equal to 3 upon 2 into t. Now this is a general equation between y and t, which will give you the values of t if the value of y is known to you, and it will tell you the value of y if any value of t is known to you. So any value of y will give you a corresponding value of t now, and any value of t will give you a corresponding value of y. Now you can sort out this question A. A is what? Find the value of y when t is equal to 6. So y you are supposed to find out when t is given at 6. So in this you will do 3 upon 2 into 6, because t is given to you as 6 and you are asked to find out y. Now this you work out, so this will be 3 3s are 9, so y will be equal to 9. So answer for this A is y will be equal to 9 when t is equal to 6. Okay, for B same way the answer will be now they will ask you to find out t when the y is 4. So in this equation you take y is equal to 4 and 3 upon 2 into t. Okay, so now you are asked to find out t. Okay, so what you do is 4 into 2 upon 3 you can do. This will give you t, isn't it? This will give you 8 upon 3, right? So 8 upon 3 is the value of t. So your answer for B will be t is equal to 8 upon 3. So this is the answer for this A and B. Okay, so let me check out the answer for exercise 10 ka question number 2 and let us verify it. So here it says that ninth ka answer the question number 2 A ka answer is y is equal to 9, which we got correctly, and it says that B ka answer is 2 by 3. Of course 8 by 3 can be written as 2 by 3. Okay, so not an issue. So both the answers are correct. Okay, t is equal to 8 by 3. Behind in the book it is given 2 by 3. Now if you know already, this and this are one and the same. This is improper fraction, this is a mixed fraction, and this is a improper fraction. Is that clear? 3 2s are 6, 7 8 by 3. Okay, so both the answers are correct. Fine. So question number 2 is also done with. Now let us come to question number 3. Now I'll have to make some space for that. See, we have some lots of questions in this exercise. So I have already put these questions on the screen, but whenever I'm solving this questions, I'll have to make space, right? So that was question number 2. Now coming to question number 3. Okay, yeah. So question number 3, it says that Z is proportional to M. So let me write that Z is proportional to M. Okay, now further he says that if Z is equal to 20, okay, when M is equal to 4. Z is equal to 20, M is equal to 4. Okay. Now he's asking you to calculate A is the value of Z, when M is 7. Okay, and B part of the question is asking you to find out the value of M when Z is equal to 55. Okay, so this is a question similar to question number 2. So the solution is you have to do this way. Z is directly proportional to M, or Z varies as M. Okay, or Z is directly varying as M, whatever you say. So this can be written as Z equal to Km. Now one value of Z and M is given to you so that you can find out the value of this K. So I'll substitute those values. Z is equal to 20, K times M is 4. So this will give me K is equal to 20 upon 4, which is nothing but 5. So I get K is equal to 5. Now this K equal to 5, I'm going to re-put in this particular formula to give me Z is equal to 5M. Okay. Now this formula connecting Z and M with a constant whose value is now known. This formula we are going to use to find out this A and B. So A is find the value of Z when M is equal to 6. So Z will be equal to 5 times M is 7, no? So Z will be equal to 35. And B part of the question is find the value of M when Z is equal to 55. So 55 will be equal to 5 times M. So now M will be equal to 55 upon 5, which is equal to 11. So the answers are Z is equal to 35 and M is equal to 11 for A and B. Okay. So let me check that answer behind. And question number 3 ka answer is 35 and 11, which is absolutely correct. Fine. So that was question number 3. And I think today's session I'm going to stop here only because we have already gone for more than around half an hour. So this video I'm ending here only. We'll be continuing with the remaining questions in the subsequent videos. Okay. So goodbye. Take care, all of you. See you.